Alright, so we're going to call this 8, 25, 20. And since we're going to go 8, 25, 20, we're going to call this B. Alright. So if you go on YouTube for the notes, there will be 2 sets of notes typically for each day, an A and a B. The A would be the first set of notes that we did at the beginning of class. B would be the second set of notes that we did at the second part of the class. And what we're going to be talking about here is linear measure. Now, the first couple of examples here in the book, they're basically taking a number line or a measuring device, and don't draw this, just watch. It's going to take you longer to draw it than it is to just watch. And you're given a measuring device, and it says on here that it's in centimeters, and it goes like, 1, 2, 3, 4, 5, and it goes 6. And then right above this measuring line, they put a segment. And they call it AB. And they ask you to find the length of the segment. Okay? And this ends right exactly on 4, and it starts exactly on 1. So what is the length of segment AB? It is 1, 2, 3 centimeters long, isn't it? Everybody see that? Alright? That's the eyeball way to do it. You just count the numbers. You go, look, there's 1, there's 2, there's 3 centimeters long. That's how long it is. The other thing you can do is you can take the largest dimension, which is 4, and you can subtract the smallest dimension, which is 1. And if you take 4 minus 1, that equals 3, doesn't it? And that tells you that it's also 3 centimeters long. What? The segment doesn't start at 0. It starts at 1. You just got to count the pieces sometimes. Alright? Sometimes you just got to count the pieces. Come on in, buddy. Just hang out, get your notebook out, start writing this down. I'll get caught up with you here in a minute. So, y'all okay with that? And if you have a problem, once we get to the worksheet, it's a couple problems. They take like a paintbrush and they lay it over, if they put a paintbrush right here and a paintbrush look like that, and there's the bristles of the paintbrush. Okay, and they asked you, how long is that paintbrush? Well, it kind of goes from about 5 and it goes over here to about 6 1/4, right? So maybe like 1.25 centimeters. Agreed? Not rocket science. Okay? Alright, very good. Now, the next thing we do need to talk about that gets a little bit more technical is betweenness of points. Alright? The relationship, let's see, recall from any two numbers, A and B, there's a real number n that lies between A and B, such that, let's say this, let's write this down. Point M is between P and Q if and only if P, Q, and M are collinear, and PM plus MQ is equal to PQ. Alright, this is a much simpler concept when we draw a diagram. Point M is between P and Q if and only if P, Q, and M are collinear, which means they're on the same line. So let's get a line. Let's put P and Q on it. Here's P. Here's Q. Point M is between P and Q, so put point M in between them. See it? M is between P and Q if and only if P, Q, and M are collinear. They're collinear, aren't they? Well, isn't segment PM, isn't this red segment PM right here, P to M, plus M to Q, isn't the red segment plus the blue segment equal to the entire segment? Y'all see that? Okay? That's an important concept. It may seem crazy or simple or whatever, but we're going to use this concept. This is like segment addition postulate. Okay? The red piece plus the blue piece equals the entire, I'm going to call it right here, the black piece. Alright? So PM plus M to Q equals P to Q. Agreed? Now, can you say that, watch this, if we call the entire piece PQ, right? PQ minus PM. What is the entire black piece, P to Q, minus P to M? What does that equal to? What's left? M to Q. Good, the blue piece. See it? The black segment minus the red segment equals the blue segment. Clear? And what about if we said that PQ minus MQ? What's left? PM. Good. Alright? Segment addition postulate. That means two pieces of a segment added together equal the entire segment. But if you know the length of the entire segment and you subtract one of the segments, one of the pieces that make up the segment, aren't you left with the other piece? The length of the other piece? Yeah? Nod your head. Yeah, I hope. Maybe. Good. Alright. So let's say we get this picture. We got an XYZ right here. We got X and Y and we got Z. And we got 3A. We got Y to Z equal to 14. And we got X to Z equal to, looks like 5A minus 4. Find the values of A. Find the value of A. Alright, we got to find the value of A. A equals. Well, what did we just say? Didn't we just say that red piece plus blue piece equals entire piece? Did we just say that 3A plus 14 equals 5a minus 4. Everybody agree with that? How many of you can feel comfortable solving that right now? Raise your hand. A couple of you. The rest of you don't feel comfortable solving it? Anybody want to admit that they don't feel comfortable solving it? Okay. Alright, remember when you got variables on both sides, you got to get all the variables on one side of the equal sign? Alright, so you start this off and you subtract 3a from each side. So we get 14 equals 2a minus 4. And then we add 4 to each side. And 18 equals 2a. And what do you do next? Divide by 2. I don't know what's going on. Sounds like somebody's drilling something. Drilling a hole, running a screw into something, or I don't know. And the 2's cancel. And what's 18 divided by 2? So 9 is equal to a. Alright. So a is equal to 9. So that's an extension of the concept of red piece plus blue piece equals black piece. Okay? You guys alright with that? Alright, the last thing that we need to talk about is congruence, or the term congruent. And we're going to say congruent here's the symbol for it. It's the equal sign with the squiggly line over it. Congruent means the same. And then we're going to say if two segments are congruent, then they have the same length. Oops, that's an H. If two segments are congruent, then they have the same length. If segment, here's a segment, AB. Is segment AB congruent to segment CD? Yes. So watch, here's how you would write it. AB is congruent to CD. AB is congruent to CD. If you take this red mark, we call these tick marks right here. A red mark, a red tick mark on segment AB and a red tick mark on segment CD. If you're not given the dimension of each segment, but if each segment has one tick mark, it means they're congruent. It means that they're the same length. Alright? So that tick mark and that tick mark mean that the segments are congruent. Okay? Alright. Questions, comments, concerns? So, the second part of your practice for today is page 3 in that workbook, and go ahead and do problems 1 through 12. You'll probably finish them. What you're going to have to do on problems 6, 7, 8, and 9 is you have to draw a picture, okay? Like I did in the notes. In problems 6, 7, 8, and 9, you're going to have to go ahead and draw a picture. Alright, find the value of x and y to z if y is in between, or if y is between x and z. And that's another segment addition postulate problem. Okay?